CJ, can you do negative 5x plus 2? Can you add those two things together?
No.
No, sir. Remember, negative 5x is negative x minus x minus x minus x minus x plus 2. Right? That is 5 negative x's. Can you add 2 to that? So it is just negative 5x plus 2. Notice I even show that I'm now distributing. So 7x times negative 5x is negative 35x squared. Right? X times x. 7x times 2 is 14x. 7 times 2 and an extra x. Same thing with my negative 13. I distribute. Plus 65x. And you can use calculators, but negative 13 times negative 5 is 65. Negative 13 times 2 is negative 26. Okay?
Oh, they're gonna miss me.
Now, you cannot add any of these other terms because that's 35x squared is being subtracted, or negative x squared 35 times. That, though, is 14x's being added, and then I'm adding another, how many x's?
65.
No, there's 65 x's. That's why it's 79x minus 26. That's how I got the 79 here. Okay? 14 plus 65 is 79. Any other questions from homework before we move on? First off, does that answer your question, CJ? Okay. Any other questions from homework before we move on? Because there will be homework questions just like these three for tonight's homework, and it's an accuracy check tonight, because that was the 4th time we've had these questions.
How do you come up with the perimeter?
And this is an important thing that you need to make a note of to yourself. How do we calculate perimeter?
Add.
Add what?
Outside.
Alright? So I'm going to add my like terms, Trey. What is x plus x plus x plus x? There's my 4x. And then what is 3 minus 2?
1.
Plus 3.
1. 4.
Right? 1 plus 3 is 4. Minus 2?
2.
Mm-hmm. Okay?
I seen how you got 4x. I was going like 2.
But 3 minus 2 is 1. So there's 1 here and there's 1 here. 1 plus 1 is 2. Any other questions? We good on 22? Okay. Again, there'll be one just like 22 on tonight's check for accuracy. Really quickly, I do want to address part B on 13. I had a lot of people, which I completely understand where they got this, x squared minus 6 meters squared. And like that's an answer that I totally believe students got through making a mistake, and I'm totally cool with it. But again, if you got something like this and you ask this question, because it's x squared minus 6, what I have right here? No. So, need everyone's attention on this really quickly. Where do you think students got x squared minus 6 from? I mean, let's start at, huh?
I think they got the x squared from the 2 x's.
Okay, so how do they get x squared from that?
They multiply them.
They multiplied them, right? Because how do we calculate area?
They times height.
And I was completely okay with you leaving it right here, x plus 3 meters times x minus 2 meters. So you could have just completely left it as x plus 3 times x minus 2. Meters times meters would be meters squared, right? We all good with that idea? Notice, would this be a quadratic or linear idea?
Quadratic.
How do we know it's quadratic? Remember, exponential also has a multiplicative rate of change.
Because it's like +3, and then it's like -2.
Because it still has an exponent.
Okay, but exponential functions also have an exponent.
Um,
What about that exponent?
Second power.
The second power. Remember, a quadratic function, or an equation, explicit equation, has a second power on it, right? That's how I know it's quadratic, okay? Now, looking at it here, though, x times x would be x
X squared.
squared. How in the world do you think they got -6?
They multiply
Multiply what?
the things.
3.
3
-2.
times -2. Notice I also got an x squared minus 6, but I also got that middle term, that plus x. I need you to pay attention to this. You look like you have something to say there, Trey.
No.
Okay. I need you to pay attention to this. Remember up here with number 7, how it was 7x times -5x plus 2? But it was also -13 times -5x plus 2? You see how that's being distributed to both terms and this is being distributed to both terms? Does it look like this x is only being multiplied by x and not x minus 2? Or is x being multiplied by the entire x minus 2?
The entire.
How do we know it's by the entire thing? Is it just an x or is x minus 2 together?
Together.
It's together, thank you. RJ, make sure your mask is up there. X is being multiplied by x minus 2. That 3, is it being multiplied by just the -2 or is x minus 2 together? So it's plus 3 times.
X minus 2.
Now I can distribute. X times x,
Squared.
x squared. X times -2 would be -2x.
It's really easy just to write it. Like,
Write it out? Yeah, I know. But these are things we want to notice. 3 times x. Good job, 3x. 3 times -2. Guys, come on. Every single one of you knows 3 times -2. -6, thank you. Zay, what is -2x plus 3x? What is -2x plus 3x?
Yeah, 1.
Huh?
1 right. 1 right.
1 what?
Positive 1 x.
There we go. X squared plus 1x minus 6. Right? They forgot to distribute the x to the -2 and the 3 to the x. That's the whole issue. And Trey, I know it's easier. You were saying it's easier to write it like this probably, right? But what we will do next lesson is work on doing this distribution. So go ahead and paying attention to it now will help you next lesson. That's why I'm going ahead and showing that. But yeah, it's super easy to just leave it like this. Alright, so we are going to now look at our objectives for a task called combining linear functions. And please hear me very clearly on this. The more that you talk with each other during this task, the more fun it is. The more that you discuss these ideas, the quicker it goes, and the more easily you will get to the different interactive parts of this task. So please talk with each other. The more silently you sit there, the more time you spend silently sitting there, the more boring it's gonna be. The more you engage, the more fun it will be. Please trust me on that. Talk with each other, help each other out. But we're going to be combining linear functions. Now, here's our objectives. Our S&Ps is normal, because what do S&Ps stand for? Right? Standards for mathematical practice. These are the practices that you need to do, the things you need to engage in to help yourself learn math better and to learn these objectives. And so we want to construct viable arguments and critique the reasoning of others. What do I mean by viable arguments?
Well, that makes sense.
Arguments that make sense, arguments that are valid, arguments that have evidence. That doesn't mean that they're 100% right. It just means create an argument that has evidence that says, okay, I've thought through this thing. That's a possibility. And then critique the reasoning of others. Legitimately, the first half of this task is you just making a prediction and discussing it with the people in your group. Super chill. You don't have to be right. Most people are not right. Totally okay. But we need to try to think through and have evidence for what we're trying to do. Looking for making use of structure, paying attention to patterns that we know and things we know about linear, quadratic, and exponential functions. To understand what we're trying to get out of this task a little bit better, and to be able to look for and express regularity in repeated reasoning. Pay attention to details so that we can get better at different things. All to get to these two objectives. Is there anyone who hasn't read the objectives in a little while who wants to read? Juan, can you read the first objective for us then? It must be really hard to read 7 or 8 words.
Combine linear functions to create a new function.
So you may not be familiar with what I mean by combining linear functions. You'll see that in just a second, but we all know what a linear function is, right? Yes? Trey, what do I mean by a linear function?
You got a constant additive rate of change.
At its most fundamental level, a linear function has a constant additive rate of change. We've got to know that before we can move elsewhere, but we'll use that later. And then, Amity, can you read the second objective?
I can determine when a combination of linear functions creates a linear versus quadratic versus an exponential function.
Alright, so a combination of linear functions could create another linear, it could create a quadratic, it could create an exponential, or even something that just completely different. And so that's what we're going to try to figure out is, when does a combination create these different things? RJ, you awake over there, buddy? Someone tap him on the shoulder. He looks exhausted. Hey, RJ. There he is. I know, but I won't let you. I care about you too much. Okay, I need everyone to go to Desmos.com. I need you to log into Desmos and then put in this password. Alright, so UJFE4H. It is easiest to do, not on the graph, but on the, nope, right there. Yeah, right there. On the home page, there is a section for code. It is easiest to put it in there. Make sure you log in first, because if you are logged in, you can actually pull it back up later. Have we been into, we've been in Desmos since you've been back, right? Okay. So you have an account? Okay. So yeah, if you're logged in, you can actually get back to where you stopped. Nope, go back to, click on the Desmos thing here. Wait, you haven't logged in yet, dude.
What the login was again?
It's your email and password, dude.
Dude, I think I
Is this like a
forgot.
little test or
I
something?
think I forgot about it.
Say again, Duan?
Is this like a little test or something?
No, it's not a test. It's something to help you learn. You can click on forgot your password if you have. Try it again though. Your caps lock should not be on, dude. There we go. Then put your code right there.
Whoa, look up again. Forgot that word.
Let's go.
You can go ahead and press go. You don't need to get started yet. But yeah, go ahead and press go.
What type of function?
You still struggling to get in? You just click on forgot password and recover it.
It's on my phone.
Go get your phone real quick. Excuse me, speaking of phones, who forgot to put theirs up? 2, 4, 5.
I'm finna make a new account.
Don't make a new account. Go to forgot password.
Well, I did. It's not showing it.
Hold on. Duan, you don't have a phone today?
I got it, but that one broke.
Put it up.
That one cracked. I'm so mad.
That's unfortunate for sure.
Only on birthday.
Anything, I gotta get my phone.
CJ, no phone?
What?
Yeah, because you've already created an account.
I forgot it.
Well, you gotta remember your crap, dude. Put your email in. Now you need to go to your email.
Wait, what it called? Outlook, something like that.
Yes.
Oh, appreciate it.
Alright, who's still trying to get into Desmos? It's not come in yet?
How you sign up? No, sign up.
Dude, somebody made me log out.
I'll wait over refresh. Click over to other, see if it comes in. Alright, while some of y'all are waiting on your things to come in to your email, because we're trying to recover our email or our logins, please guys, stop losing your logins, or know your logins in general. Alright, I need y'all to pay attention while we're waiting though. So, right here it says combining linear functions. First things first. Wait, can I erase this password up here, or does someone still need it?
I need it.
You still need it? Alright, well, it's right underneath. A linear function. This is why I'm asking you to have your graphic organizer out right now, because you need to be able to think through these different features that we talked about last week.
It didn't show.
What should we know about linear? Just wait a second, Zay, and pay attention for now. Zay, pay attention for now. Alright, what did Trey say earlier about a linear function that we need to keep in mind always? Constant, additive, so we're talking about rates of change. A constant, additive rate of change, right? You don't need to write this down, I'm leaving it on the board for now. Whereas a quadratic has what type of rate of change?
Linear additive.
Linear additive, right? That's on our graphic organizer. What about an exponential? Have we already forgotten what kind of rate of change an exponential function has? Thank you. Not just multiplicative, just like linear, it is constant multiplicative. Alright. That's our rate of change idea. What else should we think about when it comes to linear, quadratic, and exponential functions? Are rate of changes the only thing we care about? Nope. What else should we pay attention to?
Ways represented.
Ways to represent it. Like what?
Like,
Like what, CJ? Algebraically, right? So let's focus right now just on an explicit equation. What do we know about the linear function in an explicit equation?
form of the line.
Well, the different equations of a line, like what?
Slope, intercept, point, slope, standard.
All right, I'm going to stop right here for a second because I do want to remind you what's most important here. What is the order, or the highest power?
The first, wait.
Yeah.
First.
Right? It's all about that first degree or first power is our highest power. Whereas with a quadratic,
Second.
it's the second power, right? There can be more done to it, but we know it's going to have an x squared. It's got a second degree or second power. Whereas with an exponential,
I need the first two.
say again,
I need to have first.
not to the first.
Oh.
What's x? What is this called? Thank you. It's exponential. The exponent is a variable. Right? These are things we want to consider. What else could we consider? Graphs, tables, right? So what we need to consider are these different representations. How can we use those representations to understand what's about to happen, right? So what type of function will result from the sum of two linear functions? A. What do I mean by a sum?
Subtraction, right?
What do y'all think about that? Subtraction? Oh, what do you think it is?
You ain't got that on book?
What do you think, Amity? Addition. Remember, I had to take it down because of the chalkboard paint. I'll try to put it back up over here. But Amity's thinking addition.
Yeah.
CJ? Addition. Brooklyn? Alright. So when we have a sum, do you agree, Zay, that's addition?
Yeah,
Okay.
now I remember.
So Trey, what do we mean by a difference of two linear functions?
Subtraction.
We're going to subtract those two linear functions, right?
Yeah, now. Yeah.
All right. So, Dewan, what do you think we mean by a product of two linear functions? You have no clue what we're going to do when it's a product.
Multiplication.
Do you agree with them? It's multiplication?
I guess so, yeah.
I mean, hey, Dewan, a sum was add, difference subtract, product multiplying those two linear functions. All right. So to wrap it up, Brooklyn, what do you think a quotient would be? Dividing, okay. And please hear me very clearly, y'all. These different representations can give you a lot of insight. You could make your own table for two different linear functions. You can make your own graph for two different linear functions. You can make your own explicit equation. It doesn't matter. What we need to do is, hey, we need to think about, right, using what you've already learned about linear, exponential, and quadratic functions, make a prediction which of those functions will result from each operation. So, if I add two linear functions, will it be linear, quadratic, exponential, or even neither, right? That's the question I'm asking here. And notice this is just making a prediction. You need to have some evidence. So think through your rates of change. Think through your equations to come up with evidence. I want to give you 60 to 90 seconds to just think on your own. After that, you're going to talk within your small group for a little bit. And I'll give you more instructions at that point. So 60 to 90 seconds to think on your own for how you would answer each of those things. You can make notes on your sheet of paper if you want. For the task. Did I not hand the task out to y'all? I think for some reason I got distracted. So make notes on your sheet to yourself what you think might be happening, and then you'll start talking with each other in a minute.
Dude, I cannot find it.
You can't find what, dude?
Yeah, I'm trying to. Probably send an email, or I can't send it yet.
You sure you typed it in right?
Yeah. That's it.
Get rid of the capitalization. Let's see if that fixes anything. All right, at this point, I do want you to start talking with those in your small group, and you should be working together. All right, so notice there's a slide for each of these. So if you go to slide 2 in Desmos. Yeah, go to slide 2 on Desmos. You should see where it's asking about the sum of linear functions there. You do not have to agree, but before you type out your answer, I want you to talk with your small group and say, hey, I think that the sum will be this, linear, exponential, quadratic, neither, or none of these, right? And give evidence to each other, right? Critiquing each other's arguments, and then making a decision of what you're going to put down. You should not spend more than 2 minutes per slide. You're just making a prediction. You don't know what the answer is. That's okay. Make a prediction, type out your answer, move on. Make sense? Okay, so let's get to thinking, talking, and discussing.
What type of question was so? Sum added two linear functions. I think it would be exponential.
I'm in. There's another password.
You're in?
Yeah, I put another password in.
Wait, no, because when you got this one, you multiply. It's not gonna be quick. What's it? No. I think it would be. Wait. Yeah, exponential. Because when you add it together, next we add two things together. Well, it's not saying. I don't know, bro. You gonna say linear? I said explain your thinking.
Yeah.
Explain. I think this is cool.
I don't care. I want you to be thinking. Serious?
So what it tell us
Why am I stuffing out?
after the question?
So, what are y'all thinking?
At first I was thinking exponential. Cause like when you add, when you add stuff repeatedly, so it didn't say it's added repeatedly. Cause when you add for repeatedly, it's multiplication. Then multiplication is exponential. I don't think it's honestly it's linear. You know.
Why do you think it's linear? We need a little bit more than just that. For example, like, what do you know about linear functions, right? We talked about the rates of change. We talked about those explicit equations. You can make graphs or tables to help you think through this. We need a little bit more detail. Rely on the things you know about linear functions, right? So if you were to take one line and you were to add it to another line, maybe that's one way to think about it. Or if you were to take the slope-intercept equation and add it to another slope-intercept equation, what would that look like? But we gotta keep moving. Hey, do you have to have the right answer? No, because it says make a prediction. Let's go.
So
Take an answer. Put some justification down. I'm just asking you to talk through it for a second before you put it down. So what are y'all thinking?
Can we put IDK?
So what'd she say? What did y'all decide for sum? You thought it'd be a linear? Why? Okay, so you think if you take a constant additive and put it with another constant additive through addition, you're gonna get the other constant additive? Okay, cool. Just wanna make sure I understand what you're thinking. So now you're thinking about the difference. What are y'all thinking with the difference?
Rate of change.
I think because of every change.
Well, is it on our own or no?
Okay, so like maybe another linear, because, I mean, addition and subtraction are really close.
I
to
picked
related.
quadratic.
Okay, cool, put it down, move on. Like,
Read
I'm
it.
just asking you to make a prediction to think
Read
through these
it.
things before we start to learn. Yo,
I think I got it.
okay, cool, then move on.
He asked me why.
Alright. I mean, you can explain it to the man. I think, wait, you put quadratic.
Oh, I'm gonna change this.
Okay, cool. Did y'all talk through your ideas? And don't forget, like, you can have a different answer than he does. That's totally okay. I just want you to at least talk through your ideas. Then click submit and go.
Oh, man. It's probably
I don't care. I'm asking you to do something. You're sitting there doing nothing.
no. I'm trying.
Time to think to move on to difference. Now you're trying not to do work. Come on. What are y'all thinking? Wait, are y'all on the same slide? She's on product. You're on difference.
Which type of function?
So what did y'all say for a difference? Okay. And you thought that sum was linear, I'm guessing?
Linear was not it. Linear wasn't it.
Well, you say that adding and subtracting are very similar, so why would sum be quadratic and difference be?
You can't just write what I write, bro. You gotta use your own brain.
Yeah, dude.
Use your brain.
Use your brain.
Alright. Come on, you gotta get something, buddy.
I ain't paying it.
We gotta keep going.
Concentration.
Hey, you're not even.
No,
like-
no, no, I'm looking up there. Trying to find subtraction. It's good shit.
Hey, what are you even looking at, dude? You're looking out the window, not at the map.
No, I'm looking up there.
Zay, I watched you look out the window.
Ronald head in the way. I gotta look back like this.
Y'all ain't fin-
Zay,
I'm
Yeah,
dead serious.
Zay.
I promise
I'm
you.
dead serious. You're lying to the wrong man.
I'm not lying. I'm like so serious right now. I was looking at the window. I promise you.
You were what?
Looking at not the window.
See, exactly. I know
was
what you
not
were
looking at the
doing, Zay.
window.
Zay.
I promise y'all, I was looking at the wall trying to find subtraction. I'm trying to
Alright,
find
keep going. If that's what you think, keep going.
I was just sharing my idea.
Well, but like, talk it through and then type it out. Like, we should be moving more quickly than we are.
This is pretty hard here, man.
No, it's not. It's a prediction. I'm not asking you to know the answer. I'm asking you to just, hey, I think this because blank. You're sitting there doing nothing.
I think exponential function.
What's weird is every other group's on quotient, y'all are sitting on difference.
Y'all.
Zay's sitting on difference.
Hey, man.
It's because you're too busy looking out the window.
I'm not trying to look at the window. I'm trying to look at the wall.
Sorry, you're right. You're not trying to look out the window. You are looking out the window.
You crazy.
See, y'all just think like, oh, you think exponential on this one. I was say you put quadratic for us in one at this point. It's fine. Come on. So why are you thinking exponential?
Because it's
Damn, we got 16 questions on these, bro. Will they tell you the grade after this?
It's not a test, dude.
I'm just saying.
How would it make sense for me to test you on something that we have not learned at
I
all in
think
class?
exponential.
That's when it's just like a just regular grade, like we want to get. We want to put the grade for it.
No, this is learning. It's not a test or an assessment.
Alright.
That's what I'm telling you, to make a prediction and move on.
I think that's ready to change. Great.
Because you haven't done it yet. In fact, I haven't done sums, differences, products, or quotients yet. It's the first time I'm doing it. So like, that's why I asked you to think through what things do you know to help you get there.
I'm on quotations.
Yes, we're going to talk about it in just a second. All right. Trey, RJ, are y'all on quotient right now?
Yeah.
I'm about to go.
I'm on quotient.
I'm about to be done with this.
Okay, once you finish that up, go ahead and skip quotient, and we'll talk about the next part of this. Okay. So, please notice, now it is time to check your predictions, right? So, what you've just done is, you've actually done one of the most important parts of mathematics. You've said, hey, I'm going to take information I know, and I'm going to make a prediction about what could happen. That's called conjecture. That's a huge part of argumentation, or developing arguments. I did not expect you to know the answer, but let me say it this way. It's a lot like the scientific process, right? Where you create a hypothesis. And then out of that hypothesis, you create an experiment or a study to figure out, is this hypothesis correct? That's what math is too, right? Math honestly is just a language for the sciences to make sense of the world around us. And so that's what we're doing here is we're developing these conjectures, these hypotheses. Before we can get started though, we're going to play around with sliders in the Desmos activity to understand how changing the values of a and b affect f of x and how changing c and d affects g of x. Alright, so I'm going to actually get out of that really quickly so that I can pull this up. So this is what I'm referring to is if you are looking at slide 7, don't go there yet, but at slide 7 you see how I have f of x equals ax plus b?
Mm-hmm.
Right? What kind of function would this be?
What is that?
F of x equals ax plus b. CJ, I think you said quadratic. What do y'all think? Let me ask you this question. What is the title of this task? Combining linear functions, right?
Linear.
What type of function would this be?
Linear.
Why should we know instantly looking at this that it is linear? There's two telltale signs.
Title.
The title, but not just that.
The variable x plus b.
CJ? A is being multiplied by x, and also note that x is to the first power. And multiplication is repeated addition, right? It's x to the first, so I'm just repeatedly multiplying. By the way, does no one recognize that equation?
No. Wait.
It doesn't remind us of any linear equations we've studied in the past?
Cursor.
Well, I know. Still finishing.
Does that look a lot like y equals mx plus b?
Yeah.
Yeah, the slope-intercept form of a line. We also have g of x is equal to cx plus d. I had to use a and b and c and d to represent two different functions. Now, I do want to talk about this really important detail before we start looking at this a little bit more clearly. Why do you think I used f of x and g of x? Why didn't I use a y?
You tell them, because you got two things. What's it called?
Two functions?
Yeah.
So why is that important to have two functions and so I didn't use y?
I think like you can't use the same variable for each one.
Is he right? I can't use the same variable for two different functions? Okay? Notice if I were to say y plus y, adding those two functions, well that's just 2y. That wouldn't add those two different functions, would it? But if I were to say f of x plus g of x, is that adding two different functions?
Yes, sir.
Okay. Similarly, if I do y times y, well that's just going to be y squared. That doesn't help me. But if I do f of x times g of x, that would be the what between those two functions?
Different.
Product.
Is that a product or a difference?
Product.
Product? Why do you think it's a product now, RJ?
We used to say different. I just got that stuck in my head.
Keep your mask up. Because it's being multiplied, right? A product is multiplication. So when I have f of x and I have g of x, I can more easily see the addition between two different functions. I can see the multiplication between two different functions. But in order to understand how this is working within Desmos, what we're going to do is we're going to spend some time here, right? Playing around with the sliders in Desmos to understand how changing the values of a and b affects f of x and how changing c and d affect g of x. You need to understand how the sliders individually affect the linear functions before you can explain the combinations of functions well, right? You got to understand how the sliders affect just the two lines, then you can look at the combinations. Very clearly connect the key elements of the lines to the equations created with the sliders, explaining how the different values affect each function. RJ, any guesses what I mean by the key elements of the lines based on those equations? Does anyone have a guess what I mean by that?
You say key elements of the line?
Right here it says connect the key elements of the lines to the equations created with the sliders. Take 60 seconds. I want you to think independently on your own. Then I'm going to give you 60 seconds to pair up or small group up and talk about it. So 60 seconds. Think about what key elements of the lines I could be talking about. Might help to look at the graphs on slide 7.
I think I know.
60 seconds, think on your own, then you can talk with them. But I appreciate you getting some ideas in there. All right, it hasn't quite been 60 seconds, but it seems like some of us have a little bit more of an idea. So take 60 seconds, talk with your partners, see what ideas you have. Did you? Yeah, go to the next slide.
You know what I'm saying?
There it is.
Key element, key part.
See how that affects the function?
Yeah. Oh, yeah.
Yeah. All right, Dwan, Amity, any ideas what key elements I'm referring to?
Looking for intercept.
Okay, intercepts might be a good thing. What else could we be looking for?
Slopes.
Slopes.
Solution.
Okay.
Yeah. What you say solution?
Yeah. Now remember, I mean, the solutions as a whole is every point on the.
It's one that make both of them true.
No, it's the intersection.
Well, are we looking for a solution to a system right now?
Oh, no.
No, remember the whole thing is about adding and subtracting and multiplying and dividing two different functions. So we don't really care about that as much.
True.
But I do want us to clarify, when you say intercepts, which intercepts are you thinking about?
X and Y.
X and Y?
Well, X and Y.
Okay. But look again at the equation.
Wow.
Do you need to look at both intercepts based on that equation? Why not?
They already got the
Remind me, what equation did you say this was?
Slope, intercept.
Okay, when you say slope-intercept, which intercept are you referring to?
Y, intercept.
So you need to be paying attention to the
Y, intercept.
slope and the
Y.
y-intercept. Sorry, I was writing stuff up there. So when I talk about looking at those sliders and seeing how those things change, what key elements I want you to focus on are A, B, C, and D affecting the slope, or are they affecting the y-intercept? Okay? So make sure you note to yourself on your sheet so that you can come back to it tomorrow the key elements that I want to identify are the slope and the y-intercept. Slope and y-intercept.
Shortest announcement.
I know, it was awesome. Wonder if they just didn't realize that they did this.
Hey parents, we're selling t-shirts for our field day on April 14th. Pick up an order form from the office or your original teacher. Sizes small and extra large are $15. 2X and 3X are $18. Turn in your money to the office during 4th or 5th period. The deadline is tomorrow.
Don't completely pack up yet.
Can we log
Senior
in?
night is next week on Tuesday.
Log out yet. I can
We will
log you
take on
out.
Brookwood. We will have our usual taco night and celebrate our great group of 2021 seniors, which includes 2 girls and 12 guys. The girls play at 5 and the boys play at 7, with our ceremony for the players in between games. Please come out and support our players. They always get excited when they see their teachers there.
I didn't even hear what they were talking about.
All prom tickets must be picked up at the end of the day on Wednesday, April 7th. Students must have ID to pick up the ticket.
If they would send me an email, I would read it.
For admission,
But like, I got a class.
cap and gown. Cap and gowns pickup is April 14th. Optional cap and gown photos are April
Crazy different
16th.
because it's math too though.
You will need to bring your
Now
own cap
we
and
talk
gowns
all
to the photo
class. Like
session.
some class we be
Please
done.
visit the school
before.
website to see available time slots.
I don't ever finish
You
before.
will then need
There's always
to email
something.
him at jddavis@tcss.net with your top 3 choices.
Alright, it doesn't look like he's gonna end before class.
Thank you, have a great day.
Okay, there we go. I just want to emphasize, make sure you have a note on this when you, wow, good job, Dewan. When you come back tomorrow, what do you want to figure out about A, B, C, and D?
The key element,
The key elements, so whether they affect the
the slope
slope
and the intercept.
or the y-intercept. So we have to clearly understand not just how they affect it, but how they interact there. So make sure you have that note to yourself. Please notice that the sheet of paper I handed out at the beginning, or right at the end of class, that is your homework for the whole week. It tells you April 5th, homework, April 6th, homework, April 7th, homework, right? So that sheet of paper has the homework for the whole week. Do tonight's homework. Especially because tonight's homework is for accuracy. What?
I was going to say put it on the board, but it said...
It's literally on the paper. It's got it all on there.
Hey, dude, try to get some more.
Here's my thing, if the announcements are so important enough, why don't they insert the period at 3:10 and take 5 minutes?